Phosphorus, Canadian Guidance Framework for the Management of Freshwater Systems. How do they handle phosphorus, and what is the guidelines for protection of aquatic life? Well, phosphorus atomic mass is a highly reactive, multivalent nonmetal of a nitrogen group in the periodic table. It is never found free in nature. And phosphate rock, which contains mineral Fe and impure tricalcium phosphate, is an important source of phosphorus. Phosphorus is an essential nutrient for all living organisms. Living matter contains about 0.3% dry weight phosphorus, and it plays a major role in biological metabolism. And when compared to other macronutrients required by biota, phosphorus is the least abundant and commonly the first nutrient to limit biological productivity. Water bodies contain low phosphorus concentrations, typically support relatively diverse and abundant aquatic life that are self-sustaining and support various water uses. However, elevated phosphorus concentrations can adversely affect aquatic ecosystems. And most of phosphorus, up to 95% in fresh water, occurs as organic phosphates, cellular constitutes of organisms, and within or absorbed to inorganic and dead particulate organic matter, and this is subsequently made available for recycling. Phosphate concentrations tend to increase with increase in total phosphorus, but the proportion of phosphate declines with increasing TP, and the turnover rate of PO4, phosphorus in limited systems, is extremely rapid, thus making its measurement difficult, and filtration of water sample prior to analysis for PO4 can overestimate biologically available phosphorus, and conventional methods for measuring the PO generally overestimate phosphorus concentrations. And based on these limitations, TP is generally recommended as a meaningful measurement of phosphorus in surface waters. In the majority of lakes, phosphorus is normally the living nutrient for algae growth. However, in some areas, nitrogen is increasingly being found to be the most important nutrient, and TP concentrations in non-polluted natural waters extend over a very wide range in highly eutrophic waters. However, the most uncontaminated fresh waters contain between 10 and 50 milligrams of TP, Wetzel, and phosphorus levels of fresh waters are generally the lowest in mountain regions of bedrock geomorphology and increase in lowland waters derived from sedimentary rock deposits in Borland Plains of Alberta, lakes rich in organic matter, and bogs to exhibit high TP concentrations. Also, the sediment of particulate phosphorus results slow but a continuous loss from water column, and phosphate is precipitated in soluble iron, calcium, or aluminum phosphate and then released slowly. And the exchange of that across the sediment-water interface is regulated by oxidation reduction interactions, which are dependent on oxygen supply, mineral solubility, and sorptive mechanisms, and the metabolic activities of bacteria and fungi, and are turbulent from physical and biotic activities as well. Lake sediments contain much higher concentrations of phosphorus than water, and under aerobic conditions, the exchange equilibria are largely unidirectional towards the sediments. So they have a derivation here. Currently, no national environmental quality guidelines exist for phosphorus, although individual provinces may have guidelines as well, and protocol for derivation guidelines for the protection of aquatic life is intended to deal specifically with toxic substances and provide numerical limits or narrative statements based on most current scientifically defensible toxicological data. And phosphorus does not fit this model because it's non-toxic to aquatic organisms at the levels forms present in the environment. However, secondary effects such as eutrophication and oxygen depletion are serious concerns. And we can see in little ecosystem of this now how this works and how it affects the water when phosphorus is high. That's why it's always a good idea to protect aquatic life and know how much phosphorus is in your water.